think first of all we should just have a really brief overview about BIA, an explanation about the technology and how it reads body composition.
Okay, we can do that. And I guess everybody who's watching this is using the BIA technology and are familiar with, I suppose, the basics of how it works. And I suppose to provide a bit of an overview, because I understand a lot of people will have done the course with Pete and had the Zoom sessions. So really to confirm, I mean, what we're doing is looking at BIA, which passes a alternating electrical current, low risk, almost no risk, about the body through the tactile points of the hands and the feet, and the tissues within the human body react to that electrical signal. And it's important, I suppose, at really early on to identify the difference between extracellular water and intracellular water, because that has a big bearing on how the BIA scan works. So extracellular water is fluid, I should say, that sits outside of cells. So I'm talking about blood, for example, plasma, tissue, fluid of that nature, versus intracellular fluid that sits within the cytosol, which is inside of the cell. And cells have what's called a phospholipid membrane, so they've got an outside covering, an external layer. And within cells, we have electrolytes and lots of other little bits and pieces that have the ability to propagate or distribute the electrical signal or provide resistance to it or impedance to it. And so the way the BIA works is how the tissue responds to that alternating current, which is on the low end, and this is not an important factor to remember, but about 50 hertz, and at the top end, the higher level is about 250 hertz. Now, why that matters is that extracellular fluid allows the low current frequency to pass through it really easily, whereas but it will bounce off the cells that have the outer layer, whereas the high frequency electrical signal just passes through everything. So that's how, like muscle, for example. So muscle is about 70% water. So with the electrical signals, both the alternating signals will pass straight through that and give us a direct and indirect measure of lean body mass, for example. Yeah. Whereas you take the low current frequency will pass through the blood and the extracellular fluid, but it'll bounce off. So we'll be able to differentiate what's bone, what's blood, what's muscle, and and what's fat, importantly, to come up with a score. And then from that, that'll appear on the scan result, and we can interpret it that way. So really, primarily, and we'll get to this, hydration status and fluid status within the body is key to the way the scanning works.
And obviously the intracellular, extracellular fluid with hydration or being dehydrated, this is going to push cell fluid up and drive external fluid down, things like this, correct?
Yeah, massively. So, and this is why it's important, we'll get to this as well, I'm sure, around how the methodology of the testing and the consistency of that. Because fat, for example, so fat is what we call anhydrous. It's got a relatively low water content. There's some water in there, but not much.
Not enough for
Not enough to make a difference. Exactly.
100%.
Whereas muscle is mostly water.
Right. Yeah.
So you take a large fat mass, it will have quite a high impedance, but it will have relatively low conductance. Whereas muscle's the other way around.
Yep.
And that's how we differentiate it. Yeah.
So it also begs to say that anything that's being held in the stomach at the time of scanning is going to come up as body fat. Anything that you're holding on your person when you scan that doesn't hold water will essentially measure as body fat.
Pretty much, yeah. And the thing that people, I suppose, probably don't factor in is that fruit, vegetables, meats, foods have a water component. So by nature of even eating those foods and having those in the gut will contribute to the total water content within the body.
Of course.
And I think that's where people have this assumption when it comes to hydration and dehydration. Someone might have a drink, right? Have a drink of water or Gatorade, or it doesn't even matter, whatever the fluid is. The initial adaptation of the body is a change in blood volume, right? Blood volume is an extracellular water. So that will actually overestimate your fat mass.
Yep.
Whereas people think, oh, well, muscle's full of water, I drink the water and it'll go into my muscle. It doesn't go straight into your muscle.
Doesn't go straight into muscle, no.
No way it will.
Yeah.
It gets, and we'll probably talk about it, but it needs to get into the muscle with glycogen. So, for example, carbohydrates or something like a creatine monohydrate or some of those other products. That's how it gets stored in the muscle.
And with true hydration too, would you say it's becoming hydrated? Obviously, is, to me, I've always found that it takes a lot longer than a few hours. To me, hydration obviously does stem from the 24 hours previous of being prepared to come and scan yourself.
100%, 100%, and yeah, that's where you can do you can do an eyeball test on your urine to determine your hydration status. If it's clear or relatively clear, you're pretty hydrated. If it glows in the dark or it's brown, you're not very well hydrated. You know, so things if you're drinking a lot of vitamins and minerals, that can often make it difficult to determine whether it's.
I know some vitamins can.
Yeah, a lot of them will. Multivitamins will make your urine pretty yellow, and so you can't really tell if I'm hydrated or not because it's bright. But over the course of the 24 hours, if you keep an eye on it, it's pretty easy to see it. And you go, I'm pretty hydrated, or I'm not. You know.
And I know we're probably going to get into this a bit later on too, when we probably go through some of the results and whatever else, but being dehydrated will also have an adverse effect on your body's ability to burn fat and to perform at its optimal peak as to what you want it to, correct? The same with nutrition.
Yeah, potentially, yeah. I mean, your hydration status is probably not as much of a player in... It'll affect your exercise capacity, which in turn will affect your performance in the gym and in your exercise ability to undertake the exercise. So from a metabolic, I suppose, fat utilisation perspective, the hydration status won't have a direct impact, but it will certainly impact on your overall
ability to perform.
And so if you can't go as far and as long or as fast and as hard, you're not going to burn as many calories, you're not going to burn as much fat. And that's kind of I suppose a secondary influence that it has on overall exercise.
Sure. So
that was a long answer to a
long answer.
Very simple question.
Went around the world with it.
I think it's good to be a little bit broad with these things. Thank you so much for listening. Thanks, Dr. Chris, and thanks, Pete, for your expertise today. If you need any more information or you would like to ask a few more questions, please feel free to contact us via our website or all the social channels. And thank you once again.